Hi, in this video it'll teach you how to draw Lewis structures. Here are the instructions. We add up the total number of valence electrons, which requires us to use a periodic table. Look at the top of the column. This tells you the number of valence in that family. 1A, group 1A has 1 valence, group 2A has 2 valence. We skip across, group 3A has 3 valence, 4 valence, 5 valence, 6 valence, 7 valence. And in the case where we use any of these, they have 8 valence electrons. So now that we can tell how many valence electrons there are on the periodic table, let's add up the valences for each of these 3. Nitrogen has 5 valence plus hydrogen has 1 times there are 4 hydrogens, and then that plus 1 means I'm going to write minus 1. And when we do our math, we're going to get 9 minus 1 equals 8 valence electrons total. This is carbon, which has 4 valence electrons, plus chlorine has 7 valence times the subscript of 4, and that's 28 plus 4, which is going to equal 32 valence electrons. Phosphorus has 5 valence plus chlorine has 7 times 6 chlorines. That negative 1 means we're going to add 1 to our total. And so now we have, this is going to be 42, 47, 48 electrons total in the valence electrons. So now that we have done step 1, which is add up the total number of valence electrons, let's do step 2. Draw the central atom and then all the other atoms single bonded around it. So never put hydrogen or fluorine in the center. So nitrogen is going to be our central atom. It's usually the least electronegative element also. And it's surrounded by 4 hydrogens. So we're going to say 1, 2, 3, 4. And we're going to draw all 4 of our hydrogens around our nitrogen in the center. Here, my central atom will be carbon because it can sustain the most bonds. 1, 2, 3, 4. And then it's going to have 4 chlorines going around it. It is most often the first element is what goes in the center. And then here, phosphorus will go in the center, and it's surrounded by 6 chlorines. 1, 2, 3, 4, 5, 6. And step 2 is done. Step 3, it says add dots to give all atoms an octet, never add dots to hydrogen. So I will not add dots to hydrogen. Nitrogen, if it has an octet or 8 around it, we do not need dots. Each of these bonds equals 2 electrons, so that goes 2, 4, 6, 8. This has an octet, it's good. This carbon has 2, 4, 6, 8. That has an octet, it's good. This chlorine has 2. So we need 4, 6, 8. So 3 pairs of electrons to give it 2, 4, 6, 8 electrons total around it. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Now, because each atom has its octet, I'm done with my dots. Same thing over here. We're going to need 3 pairs of dots around all of the chlorines. Phosphorus has more than an octet, 2, 4, 6, 8, 10, 12, and that's okay because it can do what's called exceed the octet rule. That would be any atom that is atomic number 15 or higher. Now that I have finished adding my dots, the next step says check the total number of electrons in the drawing and compare them to this number that we got in step 1. So in this drawing I have 2, 4, 6, 8. There are 8 electrons in the drawing. Since these 2 match, this one is correct and done. This one has 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Because there are a total of 32 electrons in my drawing and that matches this number, this one is done and it's correct. This one has 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48. There are 48 total electrons in this drawing. These 2 numbers match. So this one is also done. So when the two numbers match or are the same, then you are done with your drawing, and that is the correct Lewis structure. Let's evaluate it. The central atom of this one is nitrogen. It has 1, 2, 3, 4 single bonds, and it has 0 lone pairs. Lone pairs are these pairs of electrons that you see around each of these, are dots, are the lone pairs of electrons. So this central atom is carbon. It has 1, 2, 3, 4 single bonds, and the total lone pairs is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 lone pairs. Those are going to be a pair of dots. Each pair of dots is a lone pair. Here I have phosphorus as my central atom. I have 1, 2, 3, 4, 5, 6 single bonds, and then we have 3 lone pairs around each chlorine. 3 times 6 chlorines is 18 total lone pairs. Set is going to have something different about it. So first, let's add up the total number of valence for each. We have added up our total number of valence. We'll move on to step 2, which is draw your central atom with the other atoms single bonded around it. All right, that takes care of step number 2. Step number 3, add dots to everything to give them an octet, except for hydrogen. Never add dots to hydrogen. So these are good. The nitrogen so far has 2, 4, 6. We need 1 lone pair to make that have 8, an octet. Anytime you put a lone pair on the center atom only, we're going to draw kind of a bubble around it. I like to call it an alien head, just to signify that we have a lone pair on the center atom, because this lone pair of electrons is exerting a force on its neighboring atoms, these hydrogens. Next, here I need to add dots to everybody. We have on this fluorine 2, 4, 6, 8, 2, 4, 6, 8. And in xenon we have 2, 4. We need 6 and 8. And I drew that kind of to the side on purpose. You'll see why in a moment. We have 1 alien head here, and we have 1 alien head there. All right, next we're going to come over here, and we need each fluorine atom needs 3 pairs of electrons to give it an octet. And then the central atom, the chlorine in the middle, already has what appears to be an octet, 2, 4, 6, 8. So step 3 is done. Everybody's got their dots except for hydrogen. Now let's check our total and compare it to the number of valence up here. My total here is 2, 4, 6, 8 because 8 electrons matches that. This one's done. This one has 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This one has not enough electrons. So there's something special we do when there's not enough. You're going to add pairs to the center atom until you have exactly the number you're supposed to, which is this one, the 22. So I just need 1 more pair on the center atom, so I'm going to add that right here. Now you understand why I put this a little bit to the left, and that's going to give me my 3rd alien head around the center of this atom. So now that I've added that pair, we now have the 22 that we're supposed to have. This is the final answer. Finally, this one, let's check our total. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Again, not enough, which means we need to add a pair to the center atom in order to have 34. So I'm just going to kind of put that right here and draw my alien head kind of between the 2 fluorine atoms there. And now that I've done that, I've fixed the problem and we have 34. That is my final answer. Here's my final set, and it also has one thing different than the others did. First, I'm going to add up my total number of valence electrons for each of these. All right, this one has 16, this has 24, this has 18. Next step, number 2, I'm going to draw my central atom, and I'm going to draw all the other atoms bonded around it. So carbon's in the center, and then we have 2 oxygens, single bonded on both sides. Sulfur in the center, 3 oxygens, 1, 2, 3. And then nitrogen in the center and 2 oxygens, 1, 2 around it. Next step is to add dots to everything to give them octets except for hydrogens. So here, my oxygen has 2, 4, 6, 8, 2, 4, 6, 8. The carbon has 2, 4. We need 6 and 8. You would draw alien heads around those, but we're going to find that we don't need to draw the alien heads in a moment, so I'm not going to do it here. Now, around these, I need my octets, so 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, and then the sulfur so far has 2, 4, 6, here's 8. Again, you would draw an alien head, but we're not going to because something special is going to happen here. Now, we have 2, 4, 6, 8 around these oxygens, and then the nitrogen being in the middle has 2, 4, it needs 6, and then 8. All right, so I'm not drawing my alien heads because I know the result of this. When I check the number of electrons and I'm going to compare them to that total, I'm going to find, in this case, I have too many electrons, which means I'm going to take 2 lone pairs and put them together to make another bond between any carbon, nitrogen, or oxygen family element that can sustain another bond. So what that means is this total is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That is too many. So because we have too many, I'm going to take 2 of the pairs, and they are going to come together to form a new bond. So these electrons are going to form this bond right here, and that means that I no longer have those 2 pairs where they are. Here, I now have 2, 4, 6, 8, 10, 12, 14, 16, 18. So see, adding that bond and losing 2 pairs drops me down by 2 electrons. I still need only 16 in this total structure, so I'm going to have to do one more. We're going to add a bond on the other side of the carbon. This pair of electrons and this pair are going to come together and form another bond there, and then we lose those pairs in the process. We no longer have these 2 pairs. They come together and they make this bond. So that is technically my final answer. If you want to see that drawn a little more cleanly, it looks like this. Carbon with a double bond, that's a double bond, to oxygen over here, and then a double bond to the other oxygen. And notice that each oxygen should only have 2 pairs because it's going to go 2, 4, 6, 8, 2, 4, 6, 8. And then the carbon has 2, 4, 6, 8 because each dash is a pair of electrons. So now when we do the total count, we have 2, 4, 6, 8, 10, 12, 14, 16. 16 is how much we're supposed to have, so now this is the correct final answer. All right, when I count the total here, I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I have too many electrons in these, and so because I have too many, I'm going to take 2 pairs. Let's do sulfur, because sulfur definitely has to give up its lone pair, and then this oxygen. It really doesn't matter which oxygen, you can pick any of them. We're going to go ahead and just pick this one, and that's going to lose this pair, and now your final answer is going to be S with a single bond to O up here, a single bond to O over here, and then we have a double bond to oxygen, which should only have 2 pairs on it on that side. Each of these atoms has an octet now. The total is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And now that the total matches this one, we are done, and that's the Lewis structure. Finally, this one, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That is too many, and therefore I'm going to take a pair of electrons, it doesn't matter which, I'll take these, move those to join these, and they're going to form a new bond, and we'll lose these 2 pairs. Those 2 pairs are going to join to form a bond. And now if I check my total, I have 2, 4, 6, 8, 10, 12, 14, 16, 18, and 18 is what I want. So this is finished. That pair remains around the nitrogen, so I'm going to give that an alien head. Your final answer actually looks like this. Nitrogen with its 1 pair, double bonded to this oxygen, which has 2 lone pairs, single bonded to this oxygen, which has its 3 lone pairs. So my central atom is nitrogen. I have 1 single bond, and I have a total of 1, 2, 3, 4, 5, 6 lone pairs. This is sulfur in the center. I have 2 single bonds and a total of 1, 2, 3, 4, 5, 6, 7, 8 lone pairs. And then this one, the central atom is carbon. I have 0 single bonds and a total of 1, 2, 3, 4 lone pairs.